Welcome to standardsolver.com. Today I am going to show you how to calculate properties of a I section. So this is the I section we have, which has a bottom flange of 100 mm by 20 mm, a web of 10 mm by 80 mm, and a top flange of 90 mm by 30 mm. So we can see this is a series of rectangles forming this section. So let's go to standardsolver.com and calculate the section properties. So you can go to standardsolver.com by entering standardsolver.com. Yeah. So here this will work same way in inches as well. So in our case, let's do it in mm. So we set the unit to mm. Let's start modeling from the bottom flange. So the bottom flange is 100 by 20 mm. So the width is 100, and for height we enter 20. We have the option to view in equal axis or kind of unequal axis if the section is too tall compared to how wide it is. Maybe you want to turn this one off, but in our case, let's switch it on. Okay, so we entered the bottom flange. So let's enter the top flange. Sorry, let's enter the web next. So the web is 10 by 80. So we can see it created this web section. Now we need to position this web relative to the bottom flange. So we can see here in the x-axis direction, it is located at the middle of the bottom flange. So the middle is 50. Then given the web is 10 mm thick, this point of the web will be at 45. Let's enter 45. So we can see it's in the center. Then let's move it to the correct height. It is at 20. So we got it. Then let's enter the top flange, which is 90 mm wide and 30 mm tall. So let's position it. In the x direction, it is 10 mm shorter than the bottom flange. So it will be 5 mm short here and 5 mm short here. So this will be 5. Then let's move it to the top of the web, which is located at 20 plus 80, which is at 100. And 100. So now we have this section. So we can see the standard solver has calculated the properties here. So if you want to see with respect to x-axis, you can see the cross-sectional area, height of the section, which is the total height, which is 20 plus 80 plus 30, 130. The width will be same as the bottom flange, which is the widest element. Then distance of the neutral axis from top and from bottom. So if we go here, we can see the centroid is at 50 and 68.818. So 68.818. This is the second moment of area or moment of inertia with respect to y-axis. Then we can also get top and bottom section moduluses, radius of gyration, and the position of the plastic neutral axis and the plastic modulus if you are interested in these. So if you want to see the results with respect to y-axis, so you toggle to y. So now the height becomes 100 and width become 130. So height is our bottom flange and width is the total section width. Then second moment of area with respect to y-axis. That's mainly it, and you have many controls here where you can toggle them on and inspect the section you created. You can zoom in at wherever you want, then go back home. So one of the main things you need to remember is when you enter these areas, none of the areas should overlap. They should be positioned in their correct position without any overlap to get accurate results. And if you want to use inch, you can switch to inch, and all the results will be in inches. That's mainly it. Hope this helps you calculate properties of sections. You can do very complex sections if you like by entering as many rectangles areas you want. Hope this helps. Thank you.